We're going to be performing a friedelcraftalcolation using T-butylbenzene, tertiary butyl chloride, and aluminum chloride as a catalyst. In this 125 ml sidearm flask, which you normally use for doing suction filtration, by the way, I put in 10 mils of tertiary butylbenzene and 7 mils of T-butyl chloride. I'm now going to add aluminum chloride. I weighed out about 1.2 grams in this beaker, and I'm going to add a little bit first to it. And what will happen is a little bit of bubbling and such will occur. And then we'll add a little bit more. I'll let that go. Now, aluminum chloride is very reactive with atmospheric moisture, so we've got to keep this closed for the most part. Let's stir that around. There's an induction period for the reaction, which may be up to a couple of minutes. Add a little bit more. The reason that we run this reaction in a sidearm flask is because right about now I'm going to turn on the vacuum, and we can test it. Okay, we're pulling a slight vacuum on it because there's HCl being generated, and we don't want HCl gas filling up the hood and consequently the lab. So we'll let that go. And the rest of it. All right, we've waited several minutes. The reaction is principally over, so we disconnect the vacuum, and you can see the solid has formed as prescribed. Now we've got to separate the solid di-T-butylbenzene from all of the reactants which haven't reacted, and also the aluminum chloride is in there. So that's in there. So we've got to put in some ice water. So we'll make some ice water here from ice and water, and we'll carefully add it. We're going to get a reaction. You can see the reaction that we get from aluminum chloride and water. The solid you see in there is our product. So there's our product in there. And I'll add some more water. All right, put that over here. Let's get this out of the way. Now we're going to do an extraction, and we're going to use diethyl ether as our solvent. We're going to use the same sort of apparatus we've been using in the past, namely our addition separatory funnel. Make sure that the stopcock is working properly. And we're going to take some diethyl ether, which we know dissolves the solid. You can see the solid in there. It's like kind of like an oily mess. And we're going to add enough diethyl ether to dissolve it. Now, diethyl ether is less dense than water, and so the solutions that it forms in contact with water are always going to be on top. So let's get this off to the side here. Let's pour this in. We may need to add a little bit more diethyl ether, but we'll see. Pour that carefully into the, and we'll put that in there like that. Okay, that's done. Put this here. Now you can see now that there is the 2 layers that we expected. And let's shake them up, vent it. See, now we've got a clear diethyl ether layer on top. So let's mix that up, vent it. And now we're going to discard the lower layer. Okay. Now let's wash it once again with water. Let's use some of our cold water here. And that seems to work fine. Shake it up again. Okay. Once again, let the layers separate. Draw off the lower aqueous layer. Now, in order to get any acid that might still be in the diethyl ether, we're going to wash the diethyl ether layer with some sodium bicarbonate, some saturated sodium bicarbonate, and that will go in here like this. Not paying too much attention to volumes, but we try to put an equal amount of bicarbonate in there. Done with that. Out of the way here. And shake that up again. Now we've got to be careful to vent this properly, because if we don't, there's CO2 that's going to be given off in this, and we don't want the top on the funnel or the stopcock to be forced out of the separatory funnel. Okay, and there we go. Let's get this stuff out of the way here. All right, now the last thing that we're going to do is to wash the diethyl ether with some brine. Now, brine is simply a saturated solution of sodium chloride in water, and the object is to get as much water out of the diethyl ether layer as we can at this point. You can clearly see that in the other washes which had the aluminum chloride dissolved in it, that we're getting a reaction between the sodium bicarbonate and the HCl that was formed when aluminum chloride contacted water. So that shows us that the aluminum chloride was good. And now let's pour in some brine. All right, let's see. Once again, shake it up, vent. And we'll collect that in our waste flask here. Okay. And that's all the waste we've generated. And now we're going to take the diethyl ether, which has the para-ditibutylbenzene in it, and we're going to dry it over sodium sulfate. Some sodium sulfate here. In fact, let's take a little bit more diethyl ether and rinse out the funnel just to get as complete a transfer as we can.
You're going to have to turn because you're blocking the second.
Really?
Yep, of course. Look where your body is.
All right, put that over there. And we're going to add sodium sulfate to this. How much? Well, whatever you need in order to get the sodium sulfate free flowing. And that looks pretty good. And I would say that we're going to now stop it at this point and let the sodium sulfate completely dry the diethyl ether before we strip it off on a rotary evaporator.